Hey everybody, in this video we're going to be interpreting the meaning of key features of a quadratic function in context. So what this means is we'll be actually looking at a situation that involves a quadratic function and looking at all those features, the y-intercept, the vertex, the roots, the axis of symmetry, and trying to figure out what those mean in terms of what's happening. So let's start with a story. For those of you who are watching this not in Knox County schools, what you're looking at is the Sun Sphere, which is a building that was built in Knoxville for the World's Fair. And, in keeping with that World's Fair theme, here's our situation. Suppose I want to celebrate the Petro, which is a food, like it's a chain of restaurants that we have here in town. But it started at the World's Fair, and it's really just chili and other fixings over top of corn chips. Really delicious. But to celebrate this, we have that from the World's Fair, we have the Sun Sphere from the World's Fair, so I'm just going to launch the ingredients for a Petro off the top of the Sun Sphere out of a homemade cannon because, of course, I'm weird that way. So what will happen is these ingredients, just like anything else under the Earth's gravity, if we're ignoring air resistance, will travel in a parabola. And so it would come off the top, fly out this way, and then land on some poor unsuspecting stranger. Now, what's interesting about this is if we start looking at sort of the important points along the path of this object's travel. So there are 3 points in particular that I want to bring your attention to. There's this point right here, which is where it was launched from. There's this point, which is where it's at its highest. So this is the highest off the ground that it gets. And there's this point right here where it hits the ground. And so notice there's no trickeration here. This is nothing but common sense. Every single situation like this is going to have those 3 points. But what I'm going to do now is I'm going to add some mathematical structure to this. And so the first thing I'm going to do is I'm going to add axes. And so here you can see I've added a y-axis that runs right through the launch point. That's pretty typical. We want to do that so that we are starting at 0 on our x-axis because that's a convenient place to start. Huh? And in this case, since I'm measuring the distance that the Petro traveled, I have that along the x-axis. And just to make sure things are nice here, I've tried to set those up as relatively equal as possible. The x-axis is a little stretched, but that's all right. We still get the idea. So notice, I've put up axes, and I've labeled what they mean. This one gives me the height of the Petro. This axis, the x-axis, gives me the distance away from our launch point. And now it's a very easy thing to set up how I would find the coordinates of each of these points. Just put the grid on there. And even more interestingly, I can now talk about them in terms of what it means in the quadratic. That launch point, when I set this up, is just my y-intercept, or my initial value. So in this case, as a coordinate pair, I can see that that is at 0, 266, and I know that's 266 because that's the height of the Sun Sphere. I've set this up purposefully that way so that that number actually has a real meaning. That 266 tells us how many feet above the ground. And I can also see my highest point. That highest point is really just the vertex of the function. So the vertex of this parabola at 25, 300 tells me 2 key points of information. The x-coordinate tells me the distance away from the Sun Sphere. So the Petro ingredients reach their highest point 25 feet away from where I launched them. And we also know the height at that highest point because that's what the y value tells us, is the height. So the highest that these things got to is 300 feet. And finally, when I hit the ground, well, that's just the x-intercept, or the root of the function. And here I can see that that is at 100, 0. And so again, that means on the x-axis we were 100 feet away from where I launched that. And 0 on the y-axis, well, that's my height. 0 means we've hit the ground. So we can see that there is a lot of information contained in just that one idea. And this is what we're going to do. We're going to look at these quadratic functions either as a graph or as an equation and look at finding the y-intercept, the vertex, the roots, and seeing what that means in the context of the situation. So here are our key steps to interpreting these quadratics. First, use the axes or the context, the description of what's going on, to find the meaning of the domain, that is the x values, and the range. In the case of that sun sphere example I just gave you, the domain describes the distance left to right from the launch point, and the range describes the height. Next, identify what point of interest you're looking for. So are you looking for the y-intercept, the root, the vertex, whatever it is, so that you know what you're looking for. And also, if you don't have a graph, it's very, very useful to sketch that graph out so that you can see what's going on at those points, and then finally use either the graph or the equation to find what you're looking for. So here's a situation where we might have something like this, and you'll notice I'm not even asking a question here. I'm just giving you the situation. Let's say that a child tosses a baseball upward. So just kind of underhand just tosses this baseball up. The height of the ball, h, at any time t, can be found using the equation h equals negative 5t squared plus 14t plus 3. So notice before I even do that, one of the things I can do is kind of determine what the x and the y values stand for. Now I used h and t because those make more sense in context, but we kind of know this is y and this is x. So t is our domain, and it represents the amount of time that has passed. So 1 second, 2 second, whatever that may be. It'd be nice if this specified units, but it doesn't, so we can just say units of time. And we have the height of the ball, h. So my range is going to represent the height. And now that I know that, I can set up a sketch, this doesn't have to be anything great, of my two values, the height over time. And so what we know is the child is going to toss the ball upward, and so the ball's going to leave his hand, but it'll have some initial height because he's not throwing it from the ground. That wouldn't make any sense. And that the ball will go up, and then in time it will come down. And so we can find all our places of interest. We have our y-intercept, which is how high the ball was when the child initially threw it. We have our vertex, which is the highest that the ball gets to. And we have our root, which is where the ball hits the ground. So now that I know that, we can think about the types of questions that I could ask. I can ask you how high the ball was when the kid initially threw it. How high was it when it left his hand? I can ask you how high the ball went, how long it took for the ball to get to that maximum height. And eventually, when I learn how to solve these in standard form, then you'll be able to find the root of this and tell me how long it took for the ball to hit the ground. But for the time being, I just want to know how high off the ground was the ball when it left the child's hand. So for this, and notice I have a much nicer graph of this sketched out for you now. How high off the ground was the ball or when it left the child's hand? Well, initially when it left the child's hand, it hadn't gone, or it hadn't taken any time yet. So what I'm really asking here is, what was the height, h, at time 0, remember the x-axis is time, so I'm really just asking what's the y-intercept of this? Now this is a standard form equation, negative 5t squared plus 14t plus 3, and lucky for us, we are clever and we know that in y equals ax squared plus bx plus c form, the y-intercept is just c. So in this case, how high off the ground was it, or was the ball when it left the child's hand? We know it's our y-intercept, 3, and we're not told what units to use, so we'll just say 3 units. It's probably feet, though. That would make sense for a child to have their hand about 3 feet off the ground. So 3 units would be how high this was off the ground. And again, it's just a fancy way of asking what's the y-intercept of this equation. Now I can ask a more complicated question. How high off the ground was the ball at its highest point, and how long did it take to get there? Now, in order to do this, I have to know that the highest point is going to be the vertex of that function. So really what I'm trying to do is take this equation and find the vertex. Well, to find the x-coordinate of the vertex, we know from standard form that that will be the opposite of b over 2a. So in this case, b is positive 14, so the opposite of positive 14 would be negative 14, and then 2 times, negative 5, and so my x-coordinate would be negative 14 over negative 10, or positive 1.4. So I have that first part, and let me go ahead and fill this in right here. And notice that that makes sense with our graph too. If I look at it, that looks like it's about 1.4. So this seems like a plausible result so far. And then in order to find h at that point, I substitute 1.4 in for the value of t. I guess I really should have said t there, but hopefully you know what I mean. Plus 14 times 1.4 plus 3. And if ever there was a situation that called for a calculator, friends, this was it. And after crunching the numbers, I find that h is equal to 12.8. So that is the y-coordinate of my vertex. Well, now that I've found that, I've actually answered both questions. How high off the ground was the ball at its highest point? So at the vertex, its height, that would be the y-coordinate of the vertex. So at its highest point, it was 12.8 units off the ground. So for my first question, I would say 12.8 units. And how long did it take to get there? Well, that's a question of how much time did it take. Time is measured on the x-axis, so that would be 1.4 units of time, probably seconds, but since it wasn't specified, we would just say this. So again, notice that all of this is just a fancy way to ask you to find either the y-intercept, vertex, or root of a function.